Hi guys, and welcome back to another lesson in Algebra 1. This is Unit 5, Lesson 9, and this is all about linear transformations. The two things that you need to know in order to be successful in this particular lesson is I know how to transform a linear function vertically, horizontally, change the slope, and flip the line across the x and y axis. And then the second thing is I can read the function notation of a transformation and understand how it transforms. So let's go ahead and get started. So this page here is going to be quite a bit of notes, but it's going to be, going through the details of what these different transformations are. And I'm going to see if I can type this information here. So this equation right here, this is called the parent function, okay? So this is a linear equation where it's just the most basic model it can be. And so if we think about our slope-intercept formula of y equals mx plus b, and we think about our function notation, this bad boy right here, the f of x, is really just the fancy way of saying y. Okay, so anytime you see that f of x in your brain, just think that's y. That's all it is. It's just function notation. Um, the rest of this is just like our slope-intercept formula. The m is our slope. We have our x variable right here. And then plus b, that would be our y-intercept. And notice that we don't have anything here on this parent function. So it's like plus 0. And the m, there's no number there, but we do see the x, so we know that it's a 1. Okay, so our parent function is just the basic model. And if we graph this parent function, it looks just like this line that you see here. Okay, it's got a slope of 1, it goes through the origin, all that good stuff. So let me go ahead and type out what it is here. So it's got a slope. Whoops, that is yellow. Not going to be able to read that. We'll try. Okay, it's got a slope of 1, and it's got a y-intercept of 0. It goes through origin. Okay, and then the description that we can write about it is this is the linear parent function. Okay, that's all it is. It's the basic function. There is not going to be anything that we are going to draw right here because no transformation has happened. It's just the definition of the function. Okay, so let's look at this. We can have a vertical shift. Okay, so we can have a linear equation. Like if this is the parent here, we can either slide this line up and draw it like this, or we could slide it down and draw it like this. And that's exactly what we're going to do. So let's look and see what this says over here. So this first vertical transformation, if we compare this to our y equals mx plus b, this is saying that the y has shifted down 3 spaces. So for us to draw this, it's going to go down 1, 2, 3. It's going to go down to here. And let me see if I can go ahead and draw my line nice and neat. Okay, so our transformation with this one, it went down 3 spaces. Okay. Now this one, it is saying that it went up 3 spaces. It's saying y plus 3. And so it's saying it went up 1, 2, 3. So that's nice and easy. That's not too bad, but the function notation makes it look kind of scary. Okay, but we're not going to be scared. It's no big deal. Let me try to fix that a little bit. I'm drawing on the computer, so obviously it's not perfect. Let's go ahead and write our notes about this. So the parent function has been altered. How has it been altered? Well, the slope here in this case is still 1, but the y-intercept is now -3. It slid down, okay? And so what would we call this? We would say that this is translate down 3. So what can we write about this plus 3? Well, it's going to be the same idea. The slope is still 1. The parent function's slope has not changed at all, but the y-intercept moved up 3. And so the y-intercept is now 3. And so the description that we would write about that is that it translated, we translated it up 3. Okay. So that is a vertical. That's the way the vertical works, is just like you see here. Now we can do this where we have a horizontal transformation. Okay, so we can do this horizontally. Just like how we can do it vertically, we can do this horizontally. We'll make this blue. Okay, so check this. It's the same idea, but you got to be a little bit careful. Okay, we got to be, we got to be a little bit careful here. So this is kind of, I'm going to make you a little sneaky alert. Okay, this is backwards. Your brain's going to be like, oh, I know what happens. If it's -3, it's going to go to the left. That's what it sounds like it should do. But it's not. Okay. So what's going to happen is that it's actually going to go right 3. So we are going to go over here, right 3, and we can draw our line. Let's see if we can fix that here. And if that one is going right 3, then we know that this one here is going to go left 3. Okay. And so let's see. Let's go ahead and draw that. So this one, went right 3. It transformed over this way. This is going to go left 3. 1, 2, 3. And so this is going to mean left 3. Because again, it's backwards. Okay, so the horizontal one, put you a little asterisk by it, make yourself a note, and remind yourself that it is in fact backwards. Okay, let's go ahead and type out the information that we need to have in this box. So my slope is still going to be 1, and then my y-intercept is in this case also going to be -3. And then, whoops, over here, we're going to have it translated right 3. And so we need to make ourselves a little note. This is the opposite sign. Okay. You're going the opposite way. And then this one here, the slope is still 1. And then the y-intercept is 3. Okay. And you can see this here with the y-intercept. When we slid it over to the right, like this, it also ended up moving that line. So we did have a -3 y-intercept. And when we slid over here to the left, this made it have a +3 y-intercept. Oh, and I forgot to fill out that last box there. Let's see. Okay, so we are going to translate left 3. And so it's going to be opposite of the way you think it should be. All right, so if I am going a little bit fast, just pause it because, of course, I'm recording ahead of time. I'm going to erase this now, and then we'll go on and fill out the bottom parts. All right, so we've done our vertical where we went up and down. We've done our horizontal where we've gone left, right. What's another thing we can change? Well, we can make it steeper or less steep. That is going to be dilation. Okay, so this dilation is going to be like your steepness, okay? So this one, we've got a coefficient in front of your y, and then this is a fraction in front of your y. This is going to make it less steep, oh, not left. Let's see, less steep. And this is going to make it more steep. Okay. If you think about your slope in general, like this one over here, your parent function is going up 1 over 1, up 1 over 1, up 1 over 1. And then this is my parent function again. But what it's going to do when we transform it is it's going to go up 1, 2, 3 over 1, 1, 2, 3 over 1. And so now we've got to draw that line quite a bit steeper. It's got a different slope. Okay. So you can see how it transformed. It's still going through the origin. All we changed was the steepness with that. Now, on this other one here, this is going to be less steep. This slope that we're going to do is 1/3. And so what's going to happen is you're going to go up 1 over 1, 2, 3. So we're going to go here, up 1 over 3. So let's draw that one out. Okay. And so you can see that it's less steep that way. Let's go ahead and type out the information about this. So this one, my slope is no longer 1. My slope is going to be, is going to be 3. And then this one, my y-intercept is still going to be 0. It still went through origin. This one here, my slope is going to be 1/3. And then my y-intercept is still 0. So what was the description over here? What happened? So this is what we call a vertical stretch by a factor of 3. Okay, it made it more steep. And then this one here is going to be a vertical compression, like it got compressed closer down to the x-axis, a vertical compression by a factor of 3. And so it got less steep. Okay, so this one got more squished. We could even put that scientific terminology in there. That's like the, extra correct way to describe it, right? This one was stretched. Okay, so this one's going to be stretched up so it can be more steep, and then this is going to be compressed. It's squished. You can tell it's like going down some here. All right. And so that is squished down. Okay, so let's look at the this last one here. So we have done where we shifted up or down, we shifted right and left, and then we also made it more steep and less steep. So the only thing left that we can do to this is this here where we've got a negative and we've got a negative. What this is a reflection. Okay, so this is going to be like you take this line here and imagine that there is a mirror. Imagine there's a mirror and it's just going to flip. Okay. And then this one, same thing. Okay. So let's explain something about that here in the text. So let's type that out. Okay, so our slope is still going to be, let me change that to pink. Our slope is still going to be the 1. And our y-intercept is still going to be 0. So it seems like almost nothing changed, but what happened is it's reflected over the x-axis. Okay. So the reason that we know that this is reflected over the x-axis, it feels kind of weird, like some of this stuff you have to kind of think about. The reason we know it's flipped over the x-axis is that, remember, f of x is the same thing as y. That negative in front is telling us we got a negative y. So instead of a positive y, we had a negative y. So, you know, you can think about it like that. They flipped it over the x-axis. Okay, and then this one is going to be the slope is still 1. Oh, sorry, the slope is still, why did I say, oh, I didn't mean positive 1 up there. I need to go back and fix it. And the intercept, the y-intercept is 0. Why did I say that? There we go. All better now. Okay, and then this one is reflected across the y-axis. Okay, so and how we can think of that one being as reflected across the y-axis is because the x value, you know, became negative. So this is the x value became negative. So, it flipped over there. So we flipped over the y-axis. Alrighty, I'm going to clear this off and I'm going to do a couple of examples with you. There are no examples on this page of notes. We've got to go to the next page. So hang tight. If you need to pause it, pause it. Okay, on this here, this is, where you would just obviously write down your steps and help get yourself straight in your head about explaining how you know if you're going to shift up and down, shift left and right, make the slope more or less steep, and then how to flip the equation over the x and y axis. You're going to write that out. And so this is, my way of trying to help promote you to get the math information to stay in your head. Okay, so what can this look like in terms of a question? Let's go ahead and grab my highlighter. It says the graph f of x is transformed to create a graph that is reflected over the y-axis. Well, remember when we've got something reflected over the y-axis, we know that it's going to involve either this negative or this negative. So we can 100% for sure rule out this bad boy and this bad boy. Okay. So then let's think about, okay, how does it make sense, reflecting over the x-axis? Well, let's go ahead and draw a diagram first. Okay, let's say that we got this is my x, and this is my y, and it's going to be reflected over the y. Well, what happened? If you had a positive x over here, if you reflected it over the y, you went into the negative x area. I guess I should draw it that way. I was drawing it backwards. So, we can say here that it is going to be, let me grab my highlighter again. It's going to be B, okay? The A would be flipping over the x-axis. This was flipping over the y because we had a negative x and the negative x area is over here. Okay, let's look at this next one here. It says the graph f of x is transformed to create a graph that is less steep. What would be the less steep? Well, remember when we did less steep, less steep had a fraction, right? It had some sort of fraction, whatever it was, 1/3 or, anything along those lines. We needed some sort of fraction because we needed to have, a low rise and a long run. Okay. This one was going up. This one was flipping across the axis. This made it steeper, so it went more up like this. This one is less shallow. Okay, so that's how you're going to solve these. I'll do one more with you, and then y'all can work on your own. Let's look at this one. Let's go and highlight some of this. Okay, so it says the graph f of x is transformed to create a graph g of x, which is shifted 2 units up. Which graph shows that? So we need to find us one where the shifted line is 2 units up. Well, the parent function on the notes, all of it I drew as this solid line, right? So the solid line here is the parent, the parent, the parent, the parent, okay? So we're looking to see where your new line is in relation to the parent function. Well, this one, they changed the slope, right? They made it, this would be less steep. Okay, so that's not it because we're looking to see 2 units up. This one, they made it more steep. This one, we went 2 units down. So it's got to be this one, 2 units up. Okay. So that's how that works, is you just kind of, look through your notes and then you read this stuff and think about it and make notes to yourself. Until next time, bye guys.